This is Unit 11, Worksheet Day 4. A couple of things I'm going to do to save a little bit of time. I'm not going to be typing the value. You won't see me typing the values into the calculator when I am. That's just really to save time. And then I'm not going to go back to that chart just because I don't want to scroll back and forth. But whenever I'm referencing the chart, remember this is the chart that I'm talking about. So on the Day 3 note. So just so it doesn't seem mysterious why I'm changing these numbers. So the basics behind the exponents is ideally, if everything goes well, we could figure out a way to make these bases the same. Once those bases are the same, we get rid of those bases and we set the exponents equal to one another and we solve for x. In this case, my answer is 3/5. That's okay to have a fraction. We will see problems like this that end up with fractional answers. A lot of times we do that just so you can't guess what the answer would be. So again, we want to try to get these bases to be the same. Focus on the smaller base. Is there a way that I could write 8 as a power of that smaller 2? And 2 times 2 times 2, 2 to the third, is the same as 8. All right, so we're just trying to figure out a way to do that. And the reason I try to do that is now that I have exact bases, I can set the exponents equal. Make sure you distribute on the left. I do that in one step just to save myself a little bit of time. Here, I'm going to subtract that 3x over, and I get -3 equals 2x. And at any point, if you want to stop, and slow down the video, that's fine. I'm going to divide by 2. You could write this as a decimal, but as a fraction is just fine. So a lot of times on like tests and quizzes, especially on our final exam, you'll see these as fraction answers. That's just so you can't kind of guess and check. You've actually got to do the technique. So again, you focus on the smaller one. So is there a way to write 125 as a power of 5? Yes, it's 5 to the third. Okay, so that is on my list. And then I get 4x. So if you want to use a list, fine. If you want to guess and check, 5 squared, 5 to the third, 5 to the fourth, it's usually not going to take you very long to get to the number that you're looking for. This one's going to be a little bit easier. We can just subtract 3x from both sides, so I get x is equal to 6. That was nice and easy. And then we get this next one. So this is 2 to the x minus 7. And again, 128 is on my list, but if you need to guess and check, you can guess and check. And you'll figure out pretty quickly that 2 to the 7th is 128. So that's all we're doing. We ignore these bases. X minus 7 equals 14x plus 7. What I'm going to do here is I'm going to subtract this x just to keep that 14, or the coefficient of x positive. I have my plus 7 there. Then I subtract 7. Right, so that is going to give me something real weird. I'm going to get a weird fraction. That's okay. Simplify the fraction if you can. We can't here. You get -14/13, and that's the best we could do. The next problem I'm just going to start. This one, we didn't put 7 on the list, but again, I think this is a good example of like, okay, well, if I try 7 to the second, that's 49. 7 to the third is 343. So usually you don't need to go too far to get these. And if you do an exponent and it's higher or lower, and then the next exponent is higher, then we're going to deal with that change of base scenario. Here, I'm going to subtract 2x from both sides, and I get x equals 5. So not too bad, right? So we're just trying to get the same base. Now, we'll use the change of base formula here in a second, but let's review what it is. When you have log base number of another number, we can go ahead and divide those. This is what I'm going to put in the calculator that I'm not going to show this time. But here, remember that top one, you want to keep the exponents, especially this second exponent. That's what's going to mess people up. And when you put that in the calculator, you are going to get 4, right? And remember, we do not want to reduce. So I know that 5 goes into 625, but I cannot reduce that. Because it's inside of the log. This one, I'm going to circle up. So I'm going to get log base 4 of 124. And then to solve for x, all right, we just put log base 124 with that parentheses closed over 4. Man, they're pretty good. I'm just going to go ahead and put this in the calculator, and I get 3.4771 if I round up. Again, I'm not going to get too uptight about rounding up or down. We should know how to round, but if you check your answer, you'll see that 3 to the 4.771 power is pretty close to 124, right? Again, I'm going to circle up. I purposely did this one with all the ones because I want you to avoid the urge to reduce. So this is the log of 11, log base 11 of 1,111. So when I do this log 11, I cannot divide by 11. I'm not trying to reduce here. I'm just going to do the logs because that log is a function. So we're not looking at 111 or 1,111. We're looking at the log of 1,111 divided by log 11. And this is going to give me 2.9247. I would round that up. Okay, so again, do not reduce. So I'm purposely putting numbers that you would think you should be able to reduce, but you're not going to be able to. Now this one, we'll talk about and we'll see some of these, but this is log base 10 of 0.00001 equals x. Now, if you remember, we don't need this log base 10 because that is a common log. So if you put it in the calculator as log 0.00001 over log 10, it's going to give you the same answer, but that log 10 is redundant. So I type that into the calculator, and I'm just going to get -5 because this is actually 10 to the -5th power. So interesting, kind of fun one there. Now, what if I have something in front of my x? That's not a big deal. We still circle up. Log base 4 of 80 equals 5x, right? We put this into the calculator. And then when I put this into the calculator, remember, I'm going to keep that in the calculator. I know my last step is going to be to divide by 5. So I put that log base 80 over log 4. That gives me something like this. But again, I'm not going to round this up or down yet. I'm going to divide by 5 first. I leave that all in the calculator, so now when I round at the very end, I'm as accurate as I can possibly be. So it'll be 0.6322 equals x. So there we go. All right. And then we're just putting some other stuff in front of, these exponents or after these exponents. So again, all I'm going to do is circle up log base 7 of 110 equals x plus 2. I just know that when I put this stuff in the calculator, whatever I get here, I'm just going to stick a 2 on, right? Or I'm going to subtract 2 from that number. Sorry, I'm not going to stick a 2 on that. I'm just going to do -2 on my last step. So I'm going to type this into the calculator, log of 110 divided by log 7. And then that's going to give me 0.4156. I would round that up. And then you're going to subtract 2. Now, I could do that in the calculator, but all that really does is take off that 2 in front. It's always nice to check on the calculator, but shouldn't change our answer there. So whether you're multiplying by something in the exponent or adding or subtracting, you're just going to do the opposite. So that just comes after you put that in the calculator. Okay, we'll take a look at the rest of those problems in class. Thanks for watching the video.